bit of finishing up this review sheet relatively quickly, but no, you can watch it again and replay it and go back and ask questions of me too. But we got to make it somewhat efficient so this video isn't tremendously long. Okay, so here goes. We left off with polar. We need to talk about plotting those points, and I think that's a pretty quick idea. I'm going to just do one or two of them here. So if I do the 3 pi over 6, that first one, remember you actually start with the angle. You go to pi over 6, you kind of point that direction, so here's pi over 6. And then what you do is walk out 3 units from that and then plot your point. Okay, that's it, that's polar points. You go out 1, 2, 3 radial units, and that's it. So now it's not the same as if you got to the right, 1, 2, and 3, but if you the idea of polar radian units, if I marked 3 units all the way around out, the actual polar graph paper has these circles with it that go around, but really all you need to do is show me I'm pointing, I'm facing pi over 6, and I'm walking out 3 units, plot the point, done. The only other thing you want to notice is that for like this point here, -1 and 2 pi over 3, you're going to face 2 pi over 3 like this, but -1 means to walk backward 1 unit and plot the point. So here's our big point right there. It's facing 2 pi over 3 but walking back a unit. Okay. Convert polar to coordinates to rectangular form from that same problem that we're looking at. So the conversion is a pretty quick little formula. Your xy coordinates are always r cosine of theta will give you the x coordinate, and r sine of theta will give you the y coordinate. So if you just do a quick calculation on the first one you see up here, for instance, we're going to have r is 3, cosine of pi over 6, and you do this for all of them. And then notice they are unit circle values, so this is a non-calculator issue. And then r sine of theta, which is also pi over 6, same angle. And that's not what I want. This is getting you there. I do want you to go all the way to say, oh yeah, cosine of pi over 6 is the x-coordinate of pi over 6. Oh yeah, that's 3 pi over 2. So I'm sorry, what am I doing? Square root of 3 over 2. Writing funny things or saying funny things, but you know what I mean. Cosine of pi over 6 is square root of 3 over 2. And then you want to go 3 sine of pi over 6. That's the height of pi over 6. That's a half. So these numbers in parentheses here are taking the place of the trig functions over on the left, bing, right, these values that I'm getting here from the unit circle. And then, yes, simplify. So get down to like, just basics. 3 times the square root of 3 over 2 is good enough for that x-coordinate. And then on the other one, yeah, just do 3 over 2, 1.5, however you want to look at. That would be a finished product. This is x, this is y on the coordinate grid. Go right this amount, go up this much. Okay. Next one is convert the equation to polar form. Okay, so there's a couple things that we can do with this. I'm tending to go the simple route in this particular instance. So what I'm going to say is, really, I just want you to replace x and y with r and theta, their form of it, and we're going to leave it at that. What you could notice about this is actually, this is a circle with radius 4, and we could get pretty, if that's something you want to understand, remember we learned this kind of, it's like an ellipse that has no a or b underneath it. This would be over 1 squared and over 1 squared. That means it's a circle, just because the a and b are the same amount, and there's a plus sign in here. So it's kind of an ellipse with the same a and same b value. Well, we know that to be a circle. So what I'm going to do, though, is knowing that that's a circle with not radius 4, I should rewrite that. That's radius 2, isn't it? Okay, so this would be 2 squared on that side. That helps in some cases get you that, but the simple, short, cut to the chase, I just want you to know how to convert things in equations. The concept of conversion is finding an equivalent to replace it with. Well, I don't want x's. I want to replace that with r cosine of theta. Okay, that takes the place of it, plus 2 quantity squared. Done. Hey, I don't want that y in there. I want you to replace it with r sine of theta. Bam, gone. Minus 1 quantity squared, and then equal to 4. Okay, that's it. That's conversion, and I don't want to make conversion anything more than that at this point. There is, maybe I could get it to solving for r and write it in a really nice condensed form, but really I just want you to recognize the conversion values, and here's where they come from. These are in polar. You need to know this picture and know it really well. You need to know x is r cosine of theta, and y is r sine of theta. That's the part that we've been working on here. Theta is the corner, and then r is that hypotenuse. This is a right triangle that describes everything you want to know about a polar equation versus a rectangular equation. They both plot points. What you'll notice in this picture is that then we have some relationships. Hey, x is r cosine of theta, y is r sine of theta. We got that part. We also know that x squared plus y squared equals r squared. And those are the relationships. We also know if we want to find theta, we could know the relationship. Tangent of theta is y over x. Those are the big equations that we use to go back and forth between rectangular and polar. We just replace stuff. Okay, I'm going to go to another one here. It says, we're going to keep going on to 14. It says, find the trig form of the complex number negative 3 minus 2i. I'm going to clear off the rest of this, some of the screen here just to kind of get myself back in. But don't mind me, I'm just making room. Okay. But negative 3 minus 2i, you want to plot this. Plot, get graphing. Complex numbers are to be graphed. Vectors are to be graphed. Don't go without the graph or you're going to find yourself missing a key point. All right, let's imagine this is at 1, 2, 3, and then 1, 2. This is my complex point right there. That's what these are. This would be your real component, which think of it as the x-axis, and this is your imaginary part, we think of it as the y component. Okay, you can, if you want to write that in there in another bright color like I'm going to do, or this is x and this is y, that's fine. Now, to write that in, and it says convert to trig form, you really just have to know the way of converting these values, like we did for polar just a minute ago. It's kind of the same idea. This x component we're going to turn into some r. The trig version is like r cosine of theta was equal to x before, and then the y component we're going to kind of do is r sine of theta like we did before. The only thing is we're not calling r is in complex is not the radius the way we thought of it there. We don't label it r. It's the same thing. It means the same, but we call it the modulus. So this modulus is kind of our r. And if I want to define that, I actually just need the Pythagorean theorem to find it. So Pythagorean theorem on this one would be what, 3 squared and 2 squared, square rooted. So that's 9 and 4. So we're looking at the square root of 13 would be our modulus. Okay, so I'm squaring the 3 and squaring the 2, and then adding them and taking the square root of that. So now that's our modulus. Now we just need theta, and theta, you all know, is not to be measured just from willy-nilly any spot that we want. It has to be from 0. So I need to figure out from 0 how many degrees that is. I will find out the angle inside that triangle and then use it. So this angle in here is what I'm going to find inside that triangle, but I will then find from 0 how many degrees that is. And the way you find it inside the triangle is you just do inverse tangent of y over x to get that theta. And ours is negative 2 over negative 3. Okay, that's our thing, so we can just make it 2/3. And that'll get us our theta. If I go to my calculator, make sure I'm in degree mode, because these are all measured in degrees, and go second tangent 2/3, and hit enter, it gives me 33.69, which is the magnitude of that angle inside that triangle, which is all good, 33.69. But what I want to do with that is then figure out how much that is plus 180, because I want the angle from 0. So just add 180 to that. That's going to be my theta of 213.69. So now to write this in trig form, now that I have all this information, the trig form of a complex number is going to be our modulus of radical 13, cosine, our angle, which is 213, oops, sorry, 0.69, and then modulus sine of that same angle, 213. And that ends up being our end result. Okay, so there it is. It has to do with the angle from 0 and the modulus, the distance from 0 that point is. Remember, complex numbers, they're just points plotted. Okay? All right, next one, we're going to get to this complex number, and then we'll just kind of finish the first page here. Here are two they're imaginary numbers and complex numbers, in trig form, and when you multiply them, oh, these are the best. So it's a pretty simple process. I'm going to go to blue again, or maybe red. what you do is you multiply their moduli and get that first value. That's going to be 4 times 3 is 12. And then inside the cosine and the sine are simply going to be of the sum of the angles. When you're multiplying complex numbers, you simply add their angles. And so I'm going to do a color coding here with these. I'm going to add these two angles to each other to get the angle between. And it's the same two angles when you're, no matter what, pi over 3 and pi over 3 on the left hand complex number, and pi over 5 and pi over 5 on the right hand complex number. I'm going to do my product is then just the sum of those two things. So I'm going to write it out longhand at first, pi over 3 plus pi over 5, and then of course we need to get a common denominator and actually do it. So this is accurate. This is done. You know, if I were writing computer code, I just put this in and let the computer figure it out. But that's an accurate complex product of those two. Multiply the moduli, add the angles. But then ultimately we're going to have to add those two together, and these angles, I'll just highlight them right here. If I were to add those together, that'd be 5 pi plus 3 pi over 15, so that'd be 8 pi over 15. I'm doing the quick trick, and this is what I'd be looking for that angle. 8 pi over 15 is what I'm expecting inside there. Okay. Now, down below, find the product of x and y. Did it. Now we're solving systems, and so we're kind of transitioning into a different topic. I'm going to pause this video and start a new one, and then we'll go from there.